What is a mole? In chemistry, it means something completely different than in regular life, right? Regular life, this is what a mole looks like, okay? They're a blind creature, live underground, dig through holes, smell, eat insects. Here's another one. It's hard to find a cute picture of a mole. There's pretty gross looking moles out there. Or this is a mole, right? Like a person's mole. So those are sometimes chemists will joke about them and kind of put them in pictures, which is why we have a little animal mole over here. But in chemistry, there really is not. It's not related to a little animal mole at all. Okay. So what the heck is a mole? Okay. A mole is a unit in chemistry. Okay. It's a specific unit of measurement. And this unit is actually equal to 6.022 times 10 to the 23rd atoms. It could also equal particles or molecules, but I am just going to focus on atoms in this particular video. So what a mole is, it's just a representation for this super, super huge number, okay? This is the actual number. That is a very, very large number. Okay, that's why I write it in scientific notation. This super, super huge thing represents atoms, right? So remember, atoms are so, so tiny that we really can't see them, and it's hard to imagine them. And we don't want to say, well, you have 6.022 times 10 to the 23rd atoms. It's just a lot easier to say, I have 1 mole. That's just easier. It's really similar to saying, hey, can you pick me up a dozen eggs from the grocery store? Like, don't say, hey, can I have 12 eggs? Like, that's very specific. But if you just say a dozen eggs, that means you want 12 eggs. Okay. Similar to this, if you have moles, okay, if I say I want 1 mole, that means I want 6.022 times 10 to the 23rd atoms. This video is more in general about how we can measure these things. So we can't measure atoms, but what we can measure is grams. So the way the periodic table is set up is so that the grams on the periodic table will equal 1 mole, okay? So anytime a question has grams in it, you are going to use the periodic table. If you don't have one, I would pull up ptable.com. I'm going to be using that throughout these videos in case you don't have one. If you have a physical periodic table, that is great. This video is really all about molar mass, okay? So mass, remember, is grams. So this is going to be the number of grams of a specific element that equals 1 mole. Okay. So when looking at our periodic table, okay, I'm just looking at this one here. So looking at nitrogen here, there are 7, that's its atomic number, that's the number of protons. And we're going to look at this number down here at the bottom, okay? This 14.007, that is the molar mass of nitrogen, okay? If you want to use this online periodic table, you can use this one. Or if you have a physical one, find nitrogen and find where that 14.001 is, and that will be the location of your molar mass on your periodic table. For nitrogen, okay, so nitrogen is equal to 14.007, and that's going to be grams per mole. Okay. Let's look at a different element. Let's look at sulfur. Okay, so sulfur is over here, right? Sulfur molar mass is 32.06, and that's coming from right here at the bottom. So those are molar masses. Those are just for simple elements. Okay, so let's say we have some NaCl, that is just salt. So we want the molar mass of this whole thing together. So all I need to do is add up the different pieces. So we're going to have sodium, and then we're going to have chlorine, and we're going to add these two independent things together to get the total molar mass. So find sodium on the periodic table over here. Okay, sodium is 22.990. And chlorine is 35.45. Just going to add those two things together. So we just add these together and we get 58.44 grams per mole. That is the molar mass of sodium chloride. But what if we have something that has more than one of the elements in them? Okay, what if we have MgF2? Okay, that just means we're going to have one magnesium, and we're going to have fluorine, and we're going to multiply that by 2 because now we have 2 of them, and then we're just going to add that together. So fluorine is 18.998. And we have to multiply that by 2. I always recommend putting this in parentheses. Okay, a lot of people make simple algebra mistakes, and then it ends up being wrong. So anything you're multiplying by 2, just put that in parentheses to keep your math straight. Okay, now we're going to look for magnesium, and magnesium is 24.305. And we are just going to add those two different things together. All right, and this is going to be 62.301, and that is grams per mole. So that's how many grams of that thing are in 1 mole. All right, last example now coming up. So if we have some calcium phosphate, right, Ca3PO42, this is basically as complicated as it can possibly get. So we have 3 calciums, so we're going to multiply the calcium by 3. And now with this 2 on the outside, it actually goes and distributes, just like in math, to both the phosphorus and the oxygen. So that means we're going to have 2 phosphoruses, and that 2 gets multiplied by the 4, so we're going to have 8 oxygens. Another way that you could look at this, some people like to find the P with the O4 first and just kind of do that separately. And then when you get that final answer, multiply that whole thing by 2. Okay, those are both valid methods of doing this. Okay, so we're going to find each of those little individual pieces on the periodic table. So calcium is 40.078. And that's going to be multiplied by 3 because we have 3 of them. Oxygen is 16, and there's 8 of them. And then last one would be phosphorus, which is 30.974. So we're going to multiply that by 2. Again, I'm putting all these in parentheses so that the algebra really stays together. And then we're just going to add all these different things together. And our final answer is 310.18 grams per mole.